Hello, this is Mr. Schneider, and we're going to talk about pyramids today. We're going to talk about two different properties of pyramids. One is the volume, that's the amount of space it takes up, and the other one is the surface area. To calculate the volume of a pyramid, you're going to multiply the area of the base by the height and divide by 3. The way I remember this is I know that the area formula for a triangle is base times height divided by 2. And a pyramid looks a lot like a triangle, but it exists in 3 dimensions. So I use that formula: volume equals area of the base times height divided by 3. When it comes to the surface area of a pyramid, one part of the area that we need to talk about is the lateral area. And the lateral area for any polyhedron is that area of the surfaces without the base, or bases if there's 2 bases. So with a pyramid, all of our lateral surfaces are going to be triangles. And in this course, we're actually going to only deal with pyramids where we have a regular polygon at the base. So we're going to have congruent isosceles triangles as our lateral surfaces. In this case, we have a picture of a pentagonal pyramid. It's a pentagonal pyramid because the base is a pentagon. And if we wanted to calculate the surface area of the entire pyramid, we would add up the area of the lateral surfaces to the area of the base. So if we want to find the lateral area of these pyramids, given that they're regular pyramids, a regular pyramid means that you have a regular polygon at the base. One thing that we could do is we could draw a net, just like we did with our prisms. So in this case, since I have a 4-sided regular polygon at the base, I have a square at the base, so we call this a square pyramid. If I was to draw a net of the lateral surfaces, I would need to have 4 triangles. And I could show the height of each triangle as 7. This is called the slant height of the pyramid. The slant height of the pyramid starts at the vertex and runs down the face so that it's perpendicular to the edge of the base. And each edge will have to be congruent because we have a regular pyramid, which means that we have that square. So the area of a triangle we can easily calculate using base times height divided by 2. So we're going to have 8 times 7 divided by 2. 8 times 7 is 56, divided by 2 is 28. So I have 4 triangles, all of which have an area of 28. So if I wanted to calculate the lateral area, which we could call A sub L, or capital L, capital A, I could do 28 times 4. Well, 28 times 4, that's 112. And since it's an area, it's going to be a unit squared, so I'm going to say meters squared. Just notice I have music on. I'm going to turn that off. So, back to part B. In part B, it looks like we have a triangle at the base, so we should have an equilateral triangle. Since it's an equilateral triangle, when I find my lateral area, I'm going to draw 3 triangles because I need to have 1 triangle coming off of each edge of the base. The base of each triangle will measure 5 millimeters, and the height of each triangle is the slant height of the pyramid, which is 6 millimeters. Remember, the area of a triangle is equal to base times height divided by 2. So when I do 6 times 5 divided by 2, I get 15. So each one of these lateral surfaces has an area of 15. To get the total lateral area, I will multiply 15 by 3 because I have the 3 triangles, which is 45. Since it's an area, it's a unit squared, so we'll have millimeters squared. Here it says to find the lateral area of each regular pyramid given the length of one edge of the base, they're calling that E, and the slant height S. So what we could do is we could draw another net, or maybe we could come up with a formula based on what we did on these previous problems. So on these previous problems, it looks like we calculated the area of each triangle by doing the base times the height, and the base was an edge of the pyramid, and the height of the triangle was the slant height of the pyramid. We divided that by 2 to get each area, and then we multiplied by the number of lateral surfaces. So if I was going to write that in terms of the variables they gave me here, I could say that lateral area, which I could call L, or A sub L, or capital L, capital A, all are accepted, is equal to the edge of a base times the slant height divided by 2. That gives me the area of a single lateral surface. Then I have to multiply that by the number of triangles, or the number of edges on the base. So for part A right here, I have a square pyramid. So my lateral area is going to be equal to the edge, 12, times the slant height, 7, divided by 2, times the number of surfaces. Well, since it's a square pyramid, we're going to have 4 lateral surfaces. So for me, I do 12 divided by 2, which is 6. 6 times 7 is 42. 42 times 4 is 168 inches squared. Using that formula, remember, lateral area equals edge times slant height divided by 2 times the number of surfaces. We're going to use that formula to do part B too. Lateral area, I'll show you another way to write it. Capital L, capital A. Lateral area is equal to edge times slant height divided by 2 times the number of lateral surfaces. So in this case, we'll have lateral area equals edge 10 times slant height 6 divided by 2 times the number of lateral surfaces. Since this is a pentagonal pyramid, we know that it has 5 lateral surfaces. So 10 divided by 2 is 5, 5 times 6 is 30, times another 5 is 150. In this case, we're going to have kilometers squared. This is a giant pyramid, 150 square kilometers. It's a lot of space. We're going to find the volume of the pyramid. If you remember back at the beginning, we talked about volume of the pyramid because a pyramid has one base is equal to the area of the base times the height divided by 3. With our prisms, volume is equal to just area of the base times height, but with pyramids, it's area of the base times height divided by 3. They told me the area of the base. The area of the base here is 20, the height is 3, and I'm going to divide by 3. Like I said, I like to divide first, so I'll just cross out those 3's and say that volume is equal to 20. And I need to remember with a volume, it's always a cubic unit, so it's going to be meters cubed. Over here, they gave me the area of the base, they gave me the height, so I can use my formula. Volume equals area of the base times height divided by 3. So volume equals 60 times 12 divided by 3. I like to divide first, so I'm going to do 12 divided by 3 and get 4. 4 times 60 is 240, and it's a unit cubed, so I'm going to have yards cubed. Find the volume of each regular pyramid given the area of the base and the height of the pyramid. So on this one they didn't give me a diagram, but it's still the same formula. Volume equals area of the base times height divided by 3. Whenever you have a pyramid, volume equals area of the base times height divided by 3. So volume equals 72 times 5 divided by 3. I like to do my division first, so I'll do 72 divided by 3 and get 24. 24 times 5 is 120. And then it'll be a unit cubed, so I'll have meters cubed. Part B, my units match, so I'm all set there. Volume equals area of the base times height divided by 3. So volume equals the area of the base is 400, the height is 21, and I'm going to divide by 3. I like to divide first. 21 divided by 3 is 7. 7 times 400 is 2,800. And then our unit is centimeters cubed. always a cubic unit when we talk about volume. The volume of a pyramid is 0.000475 cubic meters. We can also read that as 475 millionths. If the area of the base is 75 square centimeters, find the height of the pyramid. So we can do this problem with meters or with centimeters, but we need to make things match. So I'm a big fan of doing whatever's easier for you. I know that this is a volume formula, so I'm going to have area of the base times height divided by 3 because we have a pyramid. And I'm going to change cubic meters to cubic centimeters. So a cubic meter is a box that's 1 meter by 1 meter by 1 meter. 1 meter, 1 meter, 1 meter. Well, 1 meter is 100 centimeters. So if I have a volume of 0.000475 cubic meters and I want to change that to cubic centimeters, I have to multiply 100 by 100 by 100, which is 1 million. So I have to multiply this number right here by 1 million, which really isn't that hard. All that I have to do is move the decimal place 6 places to the right. 1, 2, 3, 4, 5, 6. And this becomes 475 cubic centimeters. So I'm going to substitute in and write 475 equals 75 times the height, because the area of the base they told me was 75, divided by 3. Well, I can divide 75 by 3. I have 475 equals 25H. I'm going to divide by 25 on each side. Some of you would just throw that in your calculator. I like to think about it like money. I know that 4 quarters makes $1, so I need 16 quarters to get to $4, and then another 3 to get to 75 cents. So I end up with 19 right here. And my unit would be in centimeters because we changed everything to centimeters. You could do this problem in meters as well. We just convert the 75 square centimeters into square meters. But I think that this is the easier way to get it done. A chocolate company plans to build a pyramid of solid chocolate with a square base where each side measures 4 feet and the pyramid has an altitude of 5 feet. If the density of chocolate is 40 pounds per cubic foot, what is the mass of the chocolate pyramid? So let's start by talking about volume. It's a pyramid. Volume equals area of the base times height divided by 3. It tells me that I have a square base. So to get the area of a square, I can use side squared times height divided by 3. They told me that each side of the square is 4 feet, so I'm going to have 4 squared times the height, which is the altitude of the pyramid, that's 5 feet, divided by 3. So volume's equal to 4 squared is 16 times 5 is 80 divided by 3. That's not going to be very helpful to me in a format that I'm rounding a decimal. So I could write that as 80 over 3, or I could write it as a mixed number. 3 goes into 8 twice, with 2 left over. 3 goes into 26 times, and we end up with that 6 repeating, or 2/3. But the 80 over 3 is going to be easier for me to use in the next section. The only thing that's missing here is my unit, and it's always a cubic unit, so we're going to have feet cubed. Now what they asked me for was the density. And remember, we talked about how density equals mass divided by volume is Earth's units, right? But in math class, it's usually more useful to say mass equals density times volume. That's the way that they tend to ask it on the Regents exam. So in this case, we're going to have mass equals my density, and the unit matches, right? Because it's pounds per cubic foot. So we're going to have 40 times my volume of 80 thirds. 80 thirds. So 40 times 80, 4 times 8, that's 32, and we put 2 zeros on the end, and we divide that by 3. I don't like the improper fraction for my answer, so I'll write that as a mixed number. 3 goes into 3 once. We can't put 3 into 2. We can put 3 into 20 though. 3 goes into 20 6 times with a 2 left over, so we're going to get 6's repeating. So 1066 and 2/3, and my unit with this will be a mass unit, so we'd say pounds. This is going to be a pretty heavy pyramid. Good luck with all your pyramid work.